All right, so we're in chapter 8. We're talking about sets in chapter 8. All right, it's basically, we're starting a whole new area of mathematics here, which means it's going to be all about learning the language of this area first off. So notice it's got some weird looking language there, right? It's got this set containing 7, and then this funny looking thing right there, and then the set containing 3, 5, and 7. That little symbol there is like a Greek E, technically called epsilon. It just means element of. Just think E, element. It's a weird E. It's a Greek E, epsilon. In the Greek alphabet, alpha, beta, gamma, delta, epsilon. Anyway, so it's a Greek E. I'm not going to test you on Greek. Just think element. That's what it's saying. It's saying, hey, is 7 an element of 3, 5, 7? That's actually a weird question. I'm not sure what the answer is today. Because basically, funny. Okay, so here's the deal. If they did not have these curly brackets, if they just said, is 7 in there? We go, yeah, obviously. There it is right there. 7 is in there, right? So let me just write that here. If they said that, I'll see that. If they said 7, the answer would be yes, obviously, true. Or I guess we'd say true. True. It's a funny looking T there. True. But since they're actually saying the set containing 7. In other words, the only way you'd have that is if you actually had the set containing 7 like that. Does that make sense? That's so picky. I'm not going to put that on the test. Right? You see the deal? You'd have to actually find a set containing 7 as one of the members of the set, of the bigger set. You'd have to find a set within a set for that to be true. So since they said the set containing it, and they just put normal 3, 5, and 7 on the other side, they did not put a set containing 7. The answer is no, false. That's a weird one. Not going to be that picky on the test. All right, I didn't believe they're right. They're technically right. But that's picky. They're being picky. All right, so let's hope they're doing that. They are being so picky. All right, so they're saying the set containing 8 is not an element. Whenever you take a symbol and you slash it, it means not that thing, right? So not an element of 3, 5, and 8. Is that true? It's probably got your mind all twisted around now, huh? Okay, so let me put it this way. Yes, exactly. That's a good way to say it. True, because that is not in there. Yeah, let me just write it down. I like the way you're saying that. That's very clear. Is not. That's exactly it. Is everybody seeing it the way Monique's seeing it? That's exactly it. Right? It's true. It's not an element because they don't have this here. If they had that there, then it would be in, right? So there's a difference between, well, again, I'm not going to be that picky. I am not going to put sets within sets. I'm just surprised they're going there. So it's not, technically. All right, let's move through these. This is really picky. I am not going to do
The one with the 3 numbers inside is called what?
All right, so given the following sets, determine whether C and D are equal sets. So what does C look like? J, K, G, A, and what's D? No. Equal means they have the exact same members. Order doesn't matter. But those don't have the same members. So does C equal D? No, those are just completely different sets, right? Good on that? Easy so far? That's just a no. They'd have to have the exact. Whereas like G and H would be equal. Yeah, see G and H? So the order doesn't matter. So it'd be like if we all gathered somewhere else. It wouldn't matter what order we're standing in. We're still the same group over there as we are here, right? That's what it means. It means, is it the same collection? A set's just a collection. Order doesn't matter. So would G and H be the same collection? Absolutely. Are C and D the same collection? No, they're the same size, but they're not the same collection, right? They're not the exact same collection. So no.
What about E and F?
E and F.
It's an E and
Oh,
F.
they're being tricky.
Bracket.
Technically, that's different.
Yeah.
Yeah, whenever you got something and then the thing with a set around it, that's different.
What about J and F?
J and
Oh, yeah.
F.
That's a weird one, too.
They're being so tricky.
Yeah.
J.
Technically, E and J are the same. I don't want to get into, I mean, if you're really into, they made me take set theory classes when I did my math stuff. So yeah, I can give you more details if you're really interested. I don't know why they're being so picky. This is the same as that. This means this is the symbol for empty set, and this is clearly an empty set. So those are the same, but when they put a bracket around it, then it's something different. Because that's a set containing an empty set. Which seems like, what? Yeah, that's just weird. So I don't know why they're being weird, but they are. So I'm not going to be picky like that with you. Less? Here, I'll see it again. I just looked quick. It's saying, all counting numbers, oh, not greater. I missed the not. Not's an important word, huh? All counting numbers not greater than 6. Are these all the, well, yeah. See, they're being so picky. The counting numbers, you tell me, what numbers do you count on? What's the first number you can? You go 0? No, nobody starts at 0, right? You never count at 0. So you start at 1, right? You don't count halves, right? Those are the counting numbers. These are the whole numbers. The whole numbers start with a whole. 0. 1, 2, 3, 4, 5, and on you go. There's a difference between, so you got to know the technical definition. Honestly, I'm probably not going to put that on the test. I just don't see what that's going to do for a business major's life. I know what the counting numbers are, and they include the 0, or they don't include the 0, but the whole numbers do. I think that's dumb. That's dumb. So I'm not going to put that on the test, but you might need to know it for the homework. The whole numbers include the 0, the counting numbers don't. Otherwise, they're the same. Neither one has negatives, neither one has fractions or decimals. So let's go back to their kind of dumb question. All the counting numbers not greater than 6. Is that them? Well, it's not supposed to have 0, is it? So it's technically false because it's not supposed to have the 0. Otherwise, it would be right. Let's make sure, because I'm kind of not sure I'm right. All right, so they're saying the set containing, the collection containing 2, 3, 9. Now we're doing a new symbol. When you do, remember, this means element of, or in other words, member of, right? Does that make sense? I could say, is Alexander a member of that class? Yes, he's an element of our class, right? Is Michael a member of our class, an element of our class? Yes. Okay, so that's what L means. But this symbol, now they're changing it. This symbol, well, technically it's not this one yet. This symbol means subset of. So it's like a C. Maybe I can help you remember it this way. It's really a sideways U, but you can kind of think of it as a C. C for contained in. Now, of course, you might think, well, how's that different than element? Well, it means sub-collection. So I could say, hey, the front row, I guess that's just Alexander. The front row is a sub, or the back row is a sub-collection of this, of us all, right? So that's what this symbol means. And of course, if you do it this way, it means not a subset or sub-collection. Does that make sense? It's almost like less than or equal to, except it's contained in or equal to. Yeah, let me write it that way. That bar in the bottom does mean equal to. Contained in or equal to. That's what it means. Contained in or equal to. And the other one means not contained in or equal to. Okay, so then here's the question. Is 239 contained in or equal to 69238? Are these guys all found in here? 2, 3, 9. Yeah, they are. So we would say this is our answer. Contained in. Right? Again, the order doesn't matter. It's just a collection of objects. The order doesn't matter. So that one's a yes. Contained in. All right. Again, I'm not going to ask these weird questions on the test, but let me help you get through your homework. So what that says, 5, 10, 15. Remember what this means? Empty set. Empty set. That means is the empty set, the set containing nothing. It's the same thing as if you write a curly brackets with nothing in it. That means the set containing nothing. Is the set containing nothing a sub-collection of this group? Technically, yes. You chose nobody. I know that seems weird, doesn't it? It's like if I said, hey, I'm gonna pick somebody, I got $20 and I'm gonna pick a sub-collection of this class and all the people I pick are gonna get $20. Ready? I picked nobody. I mean, that'd be dumb, wouldn't it? But that technically is picking, you choose nobody. That is choosing out of that set. So that is true, actually. Again, I'm not gonna ask those weird questions. But choosing, that is one option, right? You could say, I'm just going to pick the 5, I'm just going to pick the 10, I'm just going to pick the 15, I'm going to pick the 5 and the 10, the 5 and the 15, I'm going to pick the 10 and the 15, I'm going to pick all 3 of them, or I'm going to pick nothing. Those are all sub-collections of the original. I just ran through all the subsets, if you're interested. You do that all the time in set theory. We'll do it more formally in a minute. But those are all considered sub-collections of the original, including picking nobody. That is a sub-collection. Empty set is a subset of every set, is how they say it in the world of set theory. All right, again, weird stuff. Okay. Okay, so now if you've got B, C, D, E, F, how many subsets, sub-collections? I don't know if you've ever done any set theory and given any thought to this kind of thing. How about we develop a formula? Want to do a little math research here without using up too much time? Let's suppose we have just 2 things. If you have just 2 elements in a set, call them A and B, call them Joe and Tom, call it number 1 and number 2. Who cares? Doesn't matter. If you have 2 items, how many ways can you choose a sub-collection of that set? How many subsets are there? You could pick both of them, or you could pick just A, or just B, or nothing. BA is not different. If you say, oh, well, I chose BA, remember the order, that's the same group. Would that be the same? Remember, order doesn't matter. So there's actually 4 different subsets, aren't there? Does that make sense? You could pick both of them, or either one individually, or nobody. So there's 4 subsets. 2 items, 4 subsets. Watch the pattern. Let's go to 3 items. How many subsets? Let's go through it. First, you can pick everybody, right? Next, now let's do all the ones involving 2. What are all the ways you can pick 2 out of the 3? So you can pick A and B, A and C, or B and C. Now for singles, you can pick just A, just B, just C, and then nobody. How many we got there? 8. 2 items, 4 subsets. 3 items, 8 subsets. Any guesses if we go to 4? How many subsets? Yeah, it's going to be, I don't want to list it all. We don't have time for that. 16. All right. What's our formula? If you have n items in your subset, I mean, it's n items in your original set, how many subsets will there be? It's kind of tricky. I'd be impressed if anybody nailed it. I want a formula, like is it n times 3 plus 1, or some kind of formula. And how, what for example, what if I thought, well, it's just 2 times n, that's the formula. How could I check if it's right? Well, when n is 2 items, it's supposed to give you 4 subsets. Does that work? If I plug in n is 2, does the formula number of subsets 2 times n work? It works for that one. For that one it works. 2 times 2 would be 4. But if you put in three subsets, you're supposed to get three elements, you're supposed to get 8 subsets. Does it work for 3? 2 times 3 would only be 6. What is it? Nice. Good work. It's 2 to the n power. See, if you do 2 up there, you get 4. You do 3 up there, 2 times 2 times 2, 8. You see, it's got to be in the power, because that's what makes you multiply by another 2 every time, huh? That's the formula. If you have n items, then you have 2 to the n power subsets. So definitely put that on your 3x5 card for our next exam. So there's the formula. All right, so let's go ahead and solve the original question now. How many items in my, I don't care what the letters are, I just care how many of them, how many there are. How many we got here? 1, 2, 3, 4, 5. So 2 to the 5th, 32. Must be 32 different subsets. So it's just about how many there are. We don't care what they are. 5 items, 32 different subsets. That's amazing, isn't it? There's 32 different sub-collections out of 5 items. But there's all the ways to pick 5 and 4 and 3 and 2, 1, and nobody. All right. Got all that down? Is that okay? So it's just 2 to the n power. So we're in a whole new area of math now. We're just kind of learning the language of this area, the verbiage of set theory. So, all right, find the number of subsets. So it's, again, it's number of subsets thing, right? Number of subsets is always 2 to the n, where n, that's supposed to say where n is number of items in the original set, right? So number of subsets equals 2 to the n, where n is the number of items in the original set. So, can you tell, do you understand what this is saying right here? Integer, don't worry about all that fancy stuff at the front. Just read the words there. It's an integer, a number, between 1 and 7. So that's 7 numbers. 1, 2, 3, 4, 5, 6, 7, right? So then how many subsets are there? Whatever 2 to the 7th is.
They're asking between. It's asking for 5. Just 5 numbers. I think it's just 2, 3, 4.
Really? They're not being very clear. You might be right. They should say inclusive or exclusive, because just saying between is not clear, but let's go see. You could be right. It probably is that. So technically, I'm not going to be, I think this is unfairly unclear, so I'll be super clear on the test. Between actually can include the endpoints or it cannot. The technical word that you're supposed to use in set theory is you say inclusive if you include the endpoints, or you say exclusive if you're excluding the endpoints. Anyway, they must mean exclusive, so they're really just meaning 2 through 6. Between, technically not on the edges. So that would just be 2, 3, 4, 5, 6, which is 5 numbers. So n is 5, so then it's 2 to the 5th, which is 32 subsets. So I would say, on a test, I would say something like between, meaning not including the endpoints. Something like that, to be clear. All right, good. So when they ask you how many subsets, 2 to the n, just got to figure out what n is. We're getting another set theory word. Have you heard of complement before? They don't mean, oh, you're such a great set. They don't mean that. They don't mean that kind of compliment. You know what the other kind of compliment is? Opposite. It means opposite. So complement is opposite. So, all right. So if U is a set of all integers, and X is an integer between 6 and 34. Now we know they really mean 7 through 33, huh? The way they use the word between. They use it exclusively, excluding the endpoints. So they mean, okay, M is the numbers 7 through 33. Is that okay? That stuff in the beginning, don't worry too much about that. That's just called set builder notation. Whenever they write that, it means the set of all X such that straight line actually is a shortcut for the word such that. But anyway, I'm not going to test you on that. You don't need to worry about all that. Just read the words. X is a number between 6 and 34. So we don't include the 6. We don't include the 34 because that's what they mean by between. We now know. So really, they just mean the numbers from 7 to 33, okay? And they want, that's what m is, and they want the complement of m. So the complement, the opposite of m is going to be the numbers 1 through 6 and 34 onward, right? Because that's the opposite of, integer, I should mention integers includes the negatives. Yeah, the word integer includes negatives. So really it's not 1 through 6, it's anything less than 6 and anything bigger than or equal to 34. Yeah, less than or equal to 6, bigger than or equal to 34. Yeah, it's B. Everybody see that? See how that's the opposite? Because we have, 7 through, if you did a number line, here's 7, here's 33. So we're going 6 on down, right? X is less than or equal to 6. And we're going 34 on up. X is greater than or equal to 34. Does that make sense? Because M goes from here to here. From 7 to 33, doesn't it? Does that make sense? M is from 7 to 33. So the opposite of M would be everything 6 on down, less than or equal to 6, and 34 on up, greater than or equal to 34. It's the opposite of M. All right, so we got B, 16, 18, 20, 22. Are all those in C? There's 16, there's 18, but 20 and 22 are not in there. They're saying B something C, and the answer came out to just be 16 and 18. Notice 16 and 18 are in both sets. 16 and 18 are in B and in C. Do you guys know what symbol? It's one of these 4 symbols. Well, you already know this means not element of, and that means element. So it's not those two. Do you know what symbol means the overlap? You turn the U over. That means intersection, technically. Intersection, or you could say overlap. That's just how I try to help people remember it. Overlap because the U is turned over. It's the overlap. It's what they have in common. That'd be like if say Monique and Michael were in this class and they had an English 1A class together, right? And so you guys would be the overlap in both collections. That's what we're doing. We're saying who's in both sets? Well, 16 and 18 are in both B and in C. So they're the overlap. The other symbol, the U, which they're going to ask us in a minute, that stands for union. That means unite or put together both sets. That would be like if our class got together with that English 1A class. All the people together and went and played softball or something. Right? That's just combine them together, unite. Whereas the U turned over is just take the overlap. So so we're getting all the verbiage here. Here's the language of set theory. Y'all good with that? So the answer to this, did I answer the question then? It was D, right? The answer was D on this one because it was B overlap C was 1618. Right up here they said the answer is 1618, so what did we do? Well, you must have taken the overlap if the answer right here was 1618. Good? So far so good? All right, so they're saying, okay, we got the collection, the set containing 16, 18, 20, 22, and we're going to do something with it, either union or overlap. With what's that symbol mean? That 0 with a slash through it? Empty set, right? I don't know why people don't just write an empty set. I think that'd be more clear. But for whatever reason, over time, that shorthand symbol emerged. A 0 with a slash. It means a set containing nothing. Equals, and the answer to this set and either union intersection with empty set is empty set. So what really goes between them? If we put a U between them, could that be right? No, it's not U. Why not? What would U mean? U would mean get them together, unite them, go play softball together, right? If you took the 16, 18, 20, 22 and united with nobody, what would you have? Well, you'd have that whole 16, 18, 20, 22. So it's not unite, or unite just puts them together. They didn't put them together, they ended up with nobody. So what did they do? Their answer was nobody. So what did they do? They did overlap. They said, what does this have in common with nothing? Well, it has nothing in common with nothing. So I'm saying these are kind of dumb questions. Does that make sense? All right. Let's keep. Okay, so here we go. So we got A, which is 1, 3, bunch of odd numbers, 1, 3, 5, 7, 9, 11. And they did something with A, that's A. They did something, either union or intersection. And B, which is what? 2, 6, 10, 14. Which is B. And the answer they got was all this. They just put them all together, didn't they? See this answer here? See how this answer, what did they do with A and B? They just put them together. So it's a union.
I think it was 16, the roster method.
We're,
16, I was
16 is the one we're asking.
okay, well, yeah, we'll get there.
Okay.
Yeah, everybody go with this one? This one's a unite. They're asking what was done with those two sets. Do we unite them or intersect them? They must have united them because they put them, whenever you get something bigger, you united them. Whenever you get something smaller, you overlap them, right? Because you just took what's in common, what's in the overlap. So that was a unite, is the answer. They must have united them because look what they got. They got something even big, had even more, had everything in it. So they got the two groups together to go play softball or whatever, right? Okay, so they're giving me A, which is 2, 4, 6, 8, 9. And then the U turned over, overlap, 4, 7, 8, 9. What's the answer going to be? So you see what they're asking? They've got the two sets A and B, and they this time are asking me to put a U turned over between them, find the overlap. That'd be like who's in both classes, right? So what numbers are in both sets? They say 4, 8, and 9, 4, 8, and 9. Yep, 4, 8, and 9. That's what they want. So you just enter those with commas. 4, 8, 9. They've already got the curly brackets around the answer box for you. See? So you just type right in here. 4, 8, 9. They've already got the curly brackets there. Good. What's in? I think they're so tricky. All right, let's see. All right, so let me explain what the little mark is. When you put that little mark up there, that means the opposite of A, or the complement, same thing, right? The complement or opposite of A. So that little mark means that, and in other textbooks, they'll put a bar over it. Same thing. Some books put a bar over it. Some put the little single quote. Either way, it means the opposite of A. Now, you got to realize what universe you're in. In other words, that's what the U is here. I'm not being spacey or something. I mean, literally, they put a U for universe, meaning that's all they're considering, right? Be kind of like if I said, hey, the people that didn't get an A on the last test need to spend a little more time on the whatever. I'm meaning out of this universe, huh? If I'm talking to you, we all have a universe in mind. I mean the people that didn't get an A, right? So I'm taking the opposite of the A group, right? There's a group that got an A, the opposite of that group. I don't mean the whole rest of the world, right? So you always got to keep in mind what universe you're speaking to. And that's what they're talking about here. They're giving me the universe. They're saying, the universe, everything under consideration that's even possible in the problem is 10, 11, 12, 13, 14, 15, and 6, just 10 through 16. Okay, so if A then is 11, 14, 15, and 16. Maybe those are the people that got A's. 11, 14, 15, and 16 got A's on the last test. Then the A complement, the people that did not get A's, would be the 10, the 12, and the 13. The other people in the universe that did not get A's. Is that good? Does that make sense what they're saying? So you always keep within, if they give you a U, if they give you a universe, then that's all things possible in that problem. So complement or opposite, single quote or the bar. The things not in A. So A was the 11, 14, 15, and 16. The other ones are not A. Okay. Okay, so let's do this. This will be a good one. So, all right, so here's the universe. There's everything possible in this problem. That's A, B, C, D, E, F, and 1 through 6. So letters A through F and numbers 1 through 6. That's all that's possible in this problem. X is the first 3 letters and numbers. Y is those other things. All right. Use the method of members of the set to find X complement intersect Y complement. All right, so here's how we should go about doing that. First, find X complement. So can we find what is X complement? What are the things not in X? That's what it means, right? Not in X. Out of the universe, I mean. So what things are not? X is ABC. So D, E, F, and X also has 1, 2, 3. So that'd be 4, 5, 6. We good so far? So that's X complement. That's the opposite of what was in X. Now, can you find Y complement? And again, you're comparing to the universe. You're saying, okay, this is Y. What are the things not in Y? But out of the things in the universe, I mean. Right? So if Y is B, D, F, then it would be A, not B, C, not D, E. Those 3 letters. So far, so good. Those are the letters not in Y. Here's Y again. And what numbers? 1, 3, 5. That's it, huh? 1, 3, 5. Are we good so far? We're almost there. So I found X complement and Y complement. Opposite of X, opposite of Y. Now, what do they want me to put in the middle of them? Overlap. That's what they put in this question right here, right? X complement, overlap, Y complement. What does that U turned over mean? It means the overlap, like who's in both X complement and Y complement. Can you tell? Who's in both? Is D, let's just go through it. I don't know. Is D in both? No. Is E in both?
Yeah.
Oh, yeah, it is, huh? There's E in both. Okay, is F in both? No. Is 4 in both?
No.
No. Is 5 in both?
Yes.
Yes, there it is. Is 6 in both?
No.
No. So it's just E and 5. There it is. E and 5 are the only 2 that are in the overlap. They're in both X complement and Y complement. Does that make sense? We good? All right. So these are more valuable. This is what I will put on the next test. You can see the next practice exam. You'll see I put questions like this. All right. So they want us to find D union E intersect F. All right. So the first thing you do, what do you always do when you got parentheses? You go there first, huh? So you do what's in the parentheses first in math. So let's do that. Let's do the D union E. Let me let you go ahead. Do the D union E. Find out what is D union E. Just that part. Don't worry about the rest of it right now. Just find the answer to D union E. What does union mean? What does that U between? Means get them together for softball. Put everybody together, right? Not just the overlap, but everybody in D and everybody in E. Put them together. Anybody that's in both, you don't list them twice. Just list them once. Just like if we went to play softball with that make-believe English 1A class that Monique and Michael were in, Monique and Michael wouldn't show up twice. Right? They would just show up once. Wearing their finite math shirt, not their English 1A shirt. Right? A Dodgers, huh? Yes. All right, we good? So what's D union E? Well, it's just all these, put with all those, and anybody that's in both, just list them once. So I'll just go 8, 11, 13, and then what, 10 and 12. It doesn't matter what order you have them in. I just did all of D, and then I threw the extra ones in E that I didn't already have. I already had 8 and 11, so I just threw 10 and 12 at the back. If you put them in a different order, that's fine. The order doesn't matter. Remember, on all these sets, never will order matter. It's just a collection of things. We good so far? Now we're going to overlap that with F. I'm just going to write down F here, even though we have it right above there. 7, 9, 10, 11, 13. Okay, now we're taking the overlap, right? That's like who's in both. So I don't know, is 8 in both? No, I'm just going to go through it here. Is 11 in both? Yeah, 11's in both. Is 13 in both? Yes, 13's in both. Is 10 in both? Yes, 10's in both. Is 12 in both? No. So 11, 13, 10. You could reorder it if that bugs you, but it doesn't really matter. 11, 13, and 10 is our answer. So do you see how we did that? We did the parentheses first, and we united. We put together D and E. Never list anybody twice. Order doesn't matter. And then overlap with F. And 11, 13, and 10 are in both sets. They're in the overlap. Questions? That's more the kind of thing I'll put on the next test, like that. All
So
good?
when you overlap, it's just the same
It's just who's in both.
on both. Right?
Yeah, the overlap. Yeah. You know what I mean? When I say overlap, I have in mind something like this, like that's like the overlap. It's the intersection, like what's in both, right? Overlap. That's what I'm visualizing. When one's laid over the other, the overlap. All right. U is the set of universities in the United States. So that's my universe, all universities in the U.S. A is the set of universities in the U.S. that have the name of a city in their name. B is the set of universities in the United States that have the word north in their name. Okay. So let's do some. What are some universities that have a city in their name? Well, obviously Fresno State. And we got another one? Michigan State. What's that?
San Jose State.
San Jose. Oh, yeah, Michigan's a state, so that wouldn't count, would it?
No.
San Jose State. San Jose State. Any college that has the name of a city. All right. Is Stanford a city? No, Stanford's not a city. It's been Palo Alto, yeah. So Stanford would not be there. Okay, now what about so there's some that are not in that. Some universities that don't have the name of a city, and Michigan State has the whole name of the state. Anyway, what about now? What has North? Can you tell me the name of North Carolina State? Yeah, good one. North Carolina State. North Carolina State. Now that would have both, wouldn't it? That would be in the overlap, wouldn't it? Because that has both North and it has the name of state, not city. North Carolina is a state. I keep messing that up. Not a city. Didn't they say city? Yes, city. They're picky. All right.
Cities with north.
What's that?
Cities with north. University.
No, that's set A. Set A is all those that have a city. Set B is all those that have north. So what are some other north ones? I don't know. Any of those. Anyway, let's go down through the problem here. Choose the correct answer. Describe A intersect B complement. A intersect B complement. in words. That gets a little tricky. What are they saying? Well, what does this symbol mean? Overlap. It means right? Because if you overlap two things, you're in both sets. You get in the picture? Right? You're in the first set and you're in the second set, right? It means and. It means both. Yeah, I should say both and. Both A and A. Now, but this is B complement. That's the opposite of B. What does that mean? What was B again? B is those that have the word north. So the opposite of that, no north in the name, right? That's the opposite. Because B is that you've got north in your name. So then the opposite of B is you don't got north in your name. You with me? So it would be colleges that have a city in their name and they both have a city in their name and they do not have north in their name. Because it's overlap, that means both and, right? Again, overlap is this kind of picture. You're in both sets, right? Getting the idea? So which one of those words have both city and not north? Today? Have the name of a city and do not have north. Yeah, nice. That way we don't have to read them all. It's just A. The other ones don't work. You can tell. This one says do not have the city. No, that's not right. Have the word north. No, they're supposed to not have the word north. Do not have the word north. That has that part, but it didn't say anything about the city. So D's not right either. It's A only. That good? You like that? It's good exercise in logic and reading. Seriously, math, word problems will teach you to read carefully. Very good for reading comprehension. Very good. Because you have to read so precisely, so carefully. It's excellent. And it's not just me that says that. There's some people say if you want to be a lawyer, who that's their job, reading contracts, writing contracts very precisely. One of the best things you can do is major in math as an undergrad for law school because it makes you a careful reader. And that's what word problems do. All right. All right, so here we go. Use set of colleges in the United States. Set of colleges that have the word junior. Junior college. That's just not popular anymore, is it? Somehow we feel insulted if we call this junior college, Fresno City Junior College. So B is the set of colleges in the United States that have the name of a U.S. hero. I can't think of one of those. Anyway, what do they want me to do? A overlap, not B. So it's A overlap. So you got to have A. You got to have junior. You got to have both junior and not a hero in your name. Is it B?
Yeah.
Junior and not a hero. Yeah, there we go. You guys got it. Same thing. All right. We're rolling. Good? Let's take a good look at it. All right, the following table gives the 52-week high and low prices, the last price, and the change in price from the day before for 5 general stocks on a recent day. So computers, their high was $54.99, their low was $18.66. What's the last? I don't know. So it gives the high and the low. The last price. The high and the low. The last price and the change in price from the day before for 5 general stocks in a recent day. So last price was $20.01 and it went down by 0.33. Oh, and it's the 52-week. It's the year high. So when we say the high and the low, that's the highest computers has been all year. That's the lowest computers has been all year, the last 52 weeks. This is what it was yesterday, and this is the change till today. Okay. Let the universal set U consist of 5 stocks listed in the table. So that's the universe. This is the whole universe as far as we're concerned. Let A contain all stocks with a high price greater than 60. So A is greater than, the high. Okay. Show some trees that are in 2 city parks. Let U be the smallest possible set that includes all the trees listed. R is the set of trees in Riverside. S is Sleepy Hollow. All right, they want S prime. They want the ones not in Sleepy Hollow. Which ones are not in Sleepy Hollow?
Riverside.
Well, like is the first one is Aspen, which is in Riverside. Is that not in Sleepy Hollow? No, it is. There it is right over there. So it's not that one. How about Birch?
It's not.
Yeah, Birch is one of them. Birch. How about Pine? No, Pine is right there, huh? Sycamore.
Only 2.
And what about Oak? No, Oak is there. So these 2 are not in Sleepy Hollow, but they're in Riverside, huh?
So we would just input them as the letter? not
I
the
can
link?
use a comma to separate. Use lowercase letters in the table. Use lowercase letters in the table to list. Now you got to type out the whole thing, I think. Birch and Sycamore.
It would just be B and S.
No, I think they want to. What makes you think it's just the first letter? I don't think they're saying that anywhere, are they?
No, because there's Aspen and then there's A, and then there's. Birch,
Oh, you're
and
right.
then
You're
Pine,
right.
and
That's
then-
what's doing it. You're totally right. Good. Be. Okay, here we go. So, a bicycle manufacturer builds 1, 3, and 10-speed models. The bicycles need both aluminum and steel. The company has available a bunch of steel, a bunch of aluminum. 1, 3, and 10-speed models need respectively 10, 15, and 25 units of steel, 12, 8, and 20 of aluminum. How many of each type of bicycle should be made in order to maximize profit? If the company makes $2 per 1-speed bike, 3 per 3, 10 per 10, what is the maximum possible profit? Okay, so they're asking, this company's making their plans, cranking out bicycles. How many 1, 3, and 10-speed bicycles? We'll call this X, Y, and Z. How about? So how many, or maybe X1, X2, X3. I don't care. X, Y, and Z is great. Whatever. So now, so that means, let's lay it out. So we have how many? 1 speed. Let me just use numbers to be easier. 1 speed, 3 speed, and 10-speed bicycles are going to be made. This is X, Y, well, let me put it up here so we can see the words still. So remember how I encouraged you to make tables for these that'll help you? Just to, and you put the letters across the top, remember? How did I know those were the letters? That's what they're asking for in the end, right? So everybody seen this game plan to help you lay out all these word problems? Just jump right to the actual question at the end. What do they want from me? How many cows and how many pigs by the 4-H'er? Or how many 1 speeds, 3 speeds, and 10 speeds for the company? So lay those out sideways. Don't put those down here. 1 speed, 3 speed, and that'll be harder. You'll have to turn everything. So put those across the top. Okay, and then let's do the different facts. The company has a bunch of steel and aluminum. 1, 3, and 10-speed models need 10, 15, and 25 steel. So you put the steel. They need 10, 15, and 25 steel. And they need, what, 12, 8, and 20 aluminum. Right? And the steel, the company has 58, so this has got to be less than or equal to 58, 675 steel, and less than or equal to 48, 520 aluminum. I'm getting those right here and here. See how I'm doing that? Everybody good so far? Am I racing ahead of you? Everybody see how I'm getting those facts? So for the steel, for the 1, 3, and 10, getting right here, 1, 3, and 10. It's 10, 15, and 25 for the steel, 12, 8, and 20. And then here's the total steel and the total aluminum, right? It's total for steel, total for aluminum. And then, so that's my inequalities, huh? And then then the other one is the Z, what we're supposed to maximize, right? What are we supposed to maximize? You want to maximize, it's $2 per bike, because they want to make max profit, right? Maximum profit. $2 per 1 speed, $3 per 3 speed, $10 per that. That's what you want to max. Good to there. Remember, you call that equal to Z, right? well, of course, I use Z up here, but whatever, you know, you can call it X1, X2, X3 maybe. Technically, that's how we did simplex. It doesn't matter. X1, X2, X3, I guess, is what I should technically do. We good? So I want to go from there and put it into a simplex tableau. But is everybody good from there, how I got the stuff out of the words? So let's go to a new page. And I'll do the same thing and then turn it into a simplex tableau. So do a box right here. Make it a little smaller. 1 speed, 3 speed, 10 speed, steel, and aluminum. And what was it? 10, 15, 25.
12, 8, 20.
12, 8, 20. And this was
2, 3, 10.
58, 6, 7, 5, and 48, 5, 20. Yeah, and then the max was 2, 3, 10 equals Z. Okay, so there is the stuff. Now, how do we turn that into a simplex tableau? Well, it's 10, 15, 20. Just put these in there. 12, 8, 20. Now, remember what happens. Oh, yeah, I did this wrong, huh? I'm sorry. I mean, everything's right, except I just should call the Z here. That's how we did the Z. The max Z goes right there, right? And this is X1, X2, X3. Good to.
Those are negative, right?
And then just move those over negative. Right. So these guys are going to jump, jump, and jump. It'll be -2, -3, -10. Kind of running out of room here. And I don't want to run out of room. Here, let me squeeze. I'm going to have to squeeze things in a little bit. A little bit more than I did. I'm just stuck with this big number here. It's supposed to be 58, 675, and 48, 520. Okay, so when we do the simplex tableau, yeah, it's 10, 15, 25, 12, 8, 20. Now, is everybody remembering? The Z, the thing you're maximizing, those have to jump over and become negative, right? -2, -3, -10, like that. And everybody good to there? And now, what do we put in this section? Remember what goes in it whenever you're doing a simplex tableau. Remember what comes. We know the answers are at the end, huh? Let me go and put those in right now. The answers are at the end. That'll be the 58, 675. Is that on the screen? Yeah, good. And the 48, 520, and 0. The Z is always 0.
S100.
Yeah, so basically it's the identity matrix. Let me help. Let's see if I make this really, really clear. It's ones down the diagonal. Remember that? And zeros everywhere else? Make sense? So once you've filled in basically the numbers from your equations, the 10, 15, 25, 12, 8, 20, and then the Z, the thing you're maximizing, those always come over so they're negative. Right? Just remember the Z, the maximum ones are always come over negative because you jump them to the other side of the equal sign. We talked about that last time. Feel free to look back on that YouTube if you want. And then you have the answers at the end, the 58, 675, 48, 520, and then 0. This is the max answer is always 0 at first. And then put ones, then the section that's missing, put ones down the diagonal and fill in zeros. Like that. Does that make sense? And then you just put that in as matrix A and tell the simplex program to do its thing. Everybody see how I got that set up? Everybody see how I added the ones down the diagonal and zeros everywhere else right before the answer column? So then you just, that's matrix A. What is it? It's 3 rows down. 3 by 1, 2, 3, 4, 5, 6, 7. 3 by 7. It's a 3 by 7. So I'm going to put it in as well. 3 by 7. Put it in matrix A. 3 by 7. Put all those numbers in there. Be careful to get them in right. One little number wrong and it's all going to malfunction, as I'm sure you've experienced. Remember the negatives, not subtraction symbols, right? Okay. And then just hit Program Simplex. And I've got some answers. So everybody got that copied down? I'm going to go to a fresh screen. So here's the answers I got in my final matrix. I got 2/5, 4, 2, 3/5, -4, 3, 1, 0, 0, and then 1/25, -4/5, 2/5, 0, 1, 0, 0, 0, 1, 2347, 1580, 23470. All right, you guys getting that? Answer matrix on your thing. So how do we do the answers? Remember, the first was x1, second was x2. This is the answer up here. Third was x3, and then start the S1, S2, S3, and these are the, oh no, not S3, the last one, right before the answer, what's this one supposed to be? Z. Remember that Z? So you just got to practice those simplex problems. So you got that down. So it's X1, X2, X3, S1, S2. The second to last is Z, and the very last is always answers. So what does that mean then? What is X1? 0. Remember, if it's not all zeros and a 1, then that letter equals 0. Look at X2. 0. Look at X3. So the ones here, you go there, 2347. Right? Wherever the 1 is, that's where you go to the answer. Okay, what about S1? 0. How about S2? It's in the middle. Go there. S2 is 1580. And Z is always this lower corner. 23,470. That's their profit. So basically, one speed is X1, that's 0. 0. They should make all 10-speed bikes. They should make 2,347 10-speed bikes. That's the best way to make profit for them. 2347 10-speed bikes, and their profit will be 23,470. Those things make the most profit. Just make those, is what the math told us. Right? It's X1, X2, X3. We don't care about S1 and S2. We never report those answers. We just give them X1, X2, and X3, and the profit, 2347 and 234070. Let's go